In this video, we will talk about how to subtract numbers in scientific notation. So I have three examples for us to work through here. Let's check out this first example. We have 4.4 times 10 to the fourth minus 2.8 times 10 to the fourth. Now, the trick here is when we're subtracting numbers in scientific notation, we want to make sure that the numbers that have a base 10, so this number and this number, we want them to have the same exponent. So we can see this one has an exponent of 4, and this one also has an exponent of 4. Now, when they have the same exponent like this, all we have to do is subtract the coefficients, or the numbers out front. So we just need to do 4.4 minus 2.8. So let's write that right here. 4.4 minus 2.8. 4 minus 8, we can't do that, so we need to borrow from the 4, make this a 3, and add 10 to this, so we get 14. 14 minus 8 is 6. We'll put down our decimal place. 3 minus 2 is 1. So we get 1.6. So our final answer is going to be 1.6. Then we'll have times 10 to whatever the exponent is that they have in common, which is a 4. So it'll be times 10 to the fourth. So that is our final answer on this one. 4.4 times 10 to the fourth minus 2.8 times 10 to the fourth is 1.6 times 10 to the fourth. All right, let's try another example. Let's say we have 3.7 times 10 to the 8th minus 5.5 times 10 to the 7th. So again, when we're subtracting numbers in scientific notation, we want to try to get it so that both base 10 numbers have the same exponent. So here we can see that this one has an exponent of 8, but this one has an exponent of 7. So they're not the same right now. So the first step is let's get them to be the same. So the way that I like to do that is identify the one with the smaller exponent. So this one has a value of 7, and ask ourselves, what do we have to do to make it an 8? Well, we just have to increase it by 1. So the trick is, if we want to increase this exponent by 1, then we need to take the decimal point on the coefficient, this 5.5, and we need to move it 1 to the left. So we need to put it right here to convert this to a 0.55. The rule is the number of positions that you move the decimal point to the left is the number of values that you can increase the exponent by. So if we move the decimal point 1 to the left, we can increase the exponent by 1 to make this an 8. So we can rewrite this like this. The first parenthesis doesn't change at all, but here we have minus 0.55 times 10. We can make the 7 an 8. So now we'll notice that the base 10 numbers, they both have the same exponent. They both have an 8. So at this point, all we have to do is just subtract the coefficients, the numbers out front. So if we do that, let's see what we get. We have 3.7 minus 0.55. So here we can imagine there's just a 0 right here. So we get 0 minus 5. We can't do that, so we borrow from the 7, make this a 6. Add 10. 10 minus 5 is 5. 6 minus 5 is 1. Bring down the decimal point. 3 minus nothing is just 3. So we get 3.15. So our final answer is 3.15 times 10 to whatever the exponent is that they share in common, which is an 8. So times 10 to the 8th. So that's our final answer on this one. All right, let's try one more example. Let's say we have 6.8 times 10 to the fourth minus 9.4 times 10 to the sixth. So again, we want to make sure that the numbers that have base 10s have the same exponent. So we can see right now they do not have the same exponent. So let's identify the one with the smaller exponent, so that would be the 4, and ask ourselves, how can we convert this to a 6? Well, we need to add 2. So the number of values that we have to increase this exponent by, 2, that's the number of places that will move the decimal point of this number to the left. So we'll move it once, twice, so it will land right here. And we can fill in a 0 right here for this placeholder. So the 6.8 will become a 0.068. So let's rewrite that right here. 0.068 times, and we said we move the decimal point 2 places to the left, so we get to increase this exponent by 2. So times 10 to the 6th. And then this parentheses doesn't change at all. We still have 9.4 times 10 to the 6th. So now the two base 10 numbers have the same exponent. So that means all we have to do at this point is just subtract the coefficients. So 0.068 minus 9.4. Now we can see that 0.068 is smaller than 9.4, so we're going to get a negative number as our answer. So when we're doing subtraction and we have a smaller number minus a larger number, so if you think about like 2 minus 4, one easy way to do that subtraction is to just flip the two numbers. So say 4 minus 2 which will turn out to be 2, and then flip the sign on your answer. So instead of a positive 2, you get a negative 2. So 2 minus 4 is negative 2. So we can use the same trick here where we say, let's actually do 9.4 minus 0.068, and we'll just flip the sign on our final answer. So here we can fill in a couple zeros. So we get 0 minus 8, we can't do that, so we need to borrow from this 0, but there's nothing to borrow from, it's also a 0, so now we need to move to the 4, borrow from the 4, make this a 3, this becomes a 10, and now we have something to borrow from, so we can borrow from this 10, make it a 9, and make this 0 a 10. So we get 10 minus 8 is 2, 9 minus 6 is 3, 3 minus 0 is 3, bring down the decimal point, and 9 minus nothing is 9. And we'll just flip the sign. Instead of a positive answer, let's make this negative. So our final answer on this one is going to be negative 9.332 times 10 to the power that they have in common, which we said was a 6. So times 10 to the 6th. So that is our final answer on this one.